All right, so we're going to take a look here then at the next page, where we begin to talk about minimum sample sizes that are required to do something. Now, in this picture over here, we can see that there's a whole lot of information in this box, and the picture itself maybe doesn't, at first glance, seem to have any relationship to what we're doing in this class. It looks like a graph. We don't deal with a lot of graphs in this course. But what we'll see here is that we have an important question that we can kind of almost lead off with based on where we ended the last video. You might recall in the last video, we were constructing a confidence interval, and at the end, we were kind of curious if we had a good interval or a bad one. And one of the things that I said in that video was that we were only 95% confident that this interval was a good one. Only 95% confident. And so there was a chance that that interval was a bad one. And therefore, we were unable to say that the actual value that we were trying to capture with that interval was actually inside of it. Like we didn't know for sure. So one of the important questions that you may have started to ask yourself in that moment was, well, Kyle, then why do we make 95% confidence intervals? I mean, why not make a 97% confidence interval so you can be more confident? Why not make a 99% confidence interval so you can be really confident? Heck, Kyle, why not make a 100% confidence interval so that way you can be guaranteed and feel perfectly confident in circling yes, you know you have a good interval? Well, I actually believe that you can construct 100% confidence intervals. And in fact, I'll demonstrate that to you right now with just a simple example. I'd like you to think really quickly ahead to exam 3. Now, when you take exam 3, after we get back from our break here, you are obviously going to get some score. I would like to right now, with 100% guaranteed accuracy, tell you a range of numbers in which your score will fall. I will produce an interval. Are you ready? Okay. Do I know what score you're going to get? No, right? There's no way I could predict ahead of time exactly how many points you're going to get on the exam. Here is my prediction for your percentage that you will earn. I predict that the percentage that you earn will be somewhere between, and I'm going to predict this with 100% confidence. I believe with 100% confidence, your score will be between 0% and 100%. No points to a perfect. I think you're going to get that or somewhere in between. How do you feel? I'm guaranteeing that with 100% confidence. I think I'm right? Like there's no way that anyone's going to score over 100%. There's no way anyone's scoring a negative percentage. So I'm definitely correct. But you'll notice that there's something very dissatisfying about my answer in that it's not really helpful. It doesn't really inform you of anything, right? Like I still have no idea realistically what you're going to score on that exam. And I haven't really narrowed it down at all. So this becomes an important idea associated with confidence intervals. We'd like to have our confidence level be very high, but what we can start to see happens is that when I have a very high level of confidence, I need to kind of start making my interval really wide. You know, what percentage of people are going to vote for somebody in the upcoming election? And you're like, gosh, I don't know, somewhere between 4% and 90%. You know, like that makes you feel really confident that you've stated, you know, or covered the right value, but it's not useful to anyone. So one of our goals here is going to be to try to create a method for determining how many people would I need to ask in order to make sure that I could make a confidence interval that has a very high level of confidence, but that is also going to be very small in width. I don't want to go from 0% to 100%. I'd like to go from like 90% to 93%. You know, that would be nice. So if you take a look back at the creation of this formula back in the box up here, you'll see that the only way I can make the interval smaller is by adjusting how much I'm going to add or subtract to p hat. Obviously, if I add a lot to p hat, then when I think about like this margin of error picture, if I added a lot in red, I'm going to make a wide interval. And if I added a tiny bit, I'm going to make a very small interval. So my goal is to make this e a very small amount, how much I'm adding and subtracting. When I look at this kind of formula for e sitting here, I'll notice that there are really two ways to do this. One way would be to change this level of confidence. We already talked about this. If my level of confidence is high, I'm going to get a wide interval. If my level of confidence is low, I'm going to get a really small interval, but I won't be confident that it's any good. The other way that I can adjust this is by manipulating the value of n. Notice if n, my sample size, is a very large number, that's going to make that whole square root over there an extremely small number. And that would mean that the thing that I'm adding to or subtracting from this p hat is very small. And so if I can make n big enough, I might be able to go ahead and determine or create a confidence interval that has a very high level of confidence and a very small width. So I'm going to go ahead and see down here in this box what exactly this box is proposing that I can do to find this sample size that I need. This is why we state that this is a minimum sample size that's going to be required to estimate p within a certain amount of error. All right, so here's the formula. The sample size required to obtain a confidence interval for a population proportion p with a specified margin of error e is this formula. I need to calculate a ZC, divide by a margin of error, square the total result, multiply by a p star, and then multiply by a 1 minus p star. At the end, I'm going to get an n, which is how many people I have to survey, and I'm always going to round that value up. Okay, by itself, that's like a whirlwind. I have no idea what that means, so here's even more information. ZC can be calculated by doing an inverse norm of the following stuff. Notice in there you just have C, your level of confidence. Okay, that's also confusing. In addition to this, we're going to have to figure out what in the world this new symbol P star is. Well, the conservative approach is to always just pick P star as 0.5, but we want to be able to be a little bit more accurate than that. Essentially, we'll say the following. If it's possible that the real value of P could be 50%, then we'll pick P star to also be 50%. But if it's not possible that P could be 50%, we'll pick our P star as close to 0.5 as possible. All right, now this can sound a little confusing, but let's take a look at example 3 here and show exactly how we could do this. All right, I know exactly what example 3 is going to be asking me, because notice right at the beginning it says, can you find the minimum sample size required for the overall proportion of voters who prefer candidate X over candidate Y to be within 2% with 90% confidence? And a whole bunch of extra information. Okay, now we'll sort through that all in a second. But notice that on the formula sheet, we're all operating down here where I have a minimum sample size. Notice that question is not asking me to do a hypothesis test. It's not asking me to build a confidence interval. It's not asking me to do any of these above options. It's saying do a minimum sample size. So I can see the formulas that I have down here. Okay. So let's see what I can come up with here in terms of some given information. So let's read this again one more time. I want to find the minimum sample size so that I can estimate the overall proportion of voters who prefer candidate X over candidate Y. I want to be within 2%. So this here is telling me about a margin of error that I want. I want to only go up 2%, down 2% from my starting point. That's how wide I want it to be. And I want to have a 90% confidence interval. So I want to keep my confidence level pretty high here. And I'm going to use my previous interval from the first example to help us estimate the value of P. Okay, so here's what I'm going to write. If I was to go back and take a look at the previous interval from example 1, we saw in that question that we thought that the real value of P would be somewhere between these numbers. This is what we thought, 0.5010 and 0.5590. So I'm going to use this to help me. All right, let's start thinking about all the different things I'm going to need to fill in the above formula that I have up here. Okay, so writing down some of these things, first thing I'm going to need is E, a margin of error. And it seems like I already have that. That's 2%. So I'll write that out as a decimal. I also have a level of confidence that I want to maintain. That's 90%. Once I have my level of confidence, I know that I could set up this ZC formula. So notice that I'm going to do 1 minus my 0.9 and then divide that by 2. Well, sometimes I can simplify this in my head pretty quickly. 1 minus 90%, or 100% minus 90%, is 10%. And 10% chopped in half is a grand total of 5%. Okay, so, oops, I forgot my inverse norm on there. Inverse norm, 0.05, 0, 1. Okay. And I can go to the calculator to crunch that, but I'm going to hold off. The last value that I need is this value P star. And according to what we had above, our general goal is to say if P could possibly be 50%, P star should be 50%. If it's not possible for P to be 50%, pick P star as close to 0.5 as possible. On the formula sheet, we just say, always pick P star to be as close to 0.5, close as possible to 0.5. All right, so let's see. We believe, based on the previous interval, that the real value of P is somewhere in here. We weren't 100% sure, but we were pretty confident. So based on this, I could say, out of all the numbers in this range, which of these is closest to 0.5? And it seems like that value should be 0.5010, that left edge. Okay, so once I have all of those numbers, I can go ahead and start to fill in the formula. I can say that my n is going to be equal to, I'm going to need my inverse norm, 0.050, 1. Going to divide that by my 0.02. I'm going to square that. I'm going to multiply by my 0.5010, and then 1 minus my 0.5010. Okay, I'm going to go to my calculator to try to crunch this and see what I come up with. Okay, so let's see. I like to start with my inverse normal calculation. Oops. 0.05, 1. And I like to do all this in the calculator slowly, step by step. You can try to type it all in at once, but then you got to be really careful with parentheses and a whole bunch of other things. I like to just think about doing this one operation at a time. So I have the top of the fraction right now, and now I want to just divide that by 0.02. I hit enter, and this is where I'm at so far. Once I've done the division, the next thing I do is I square. So I'm going to click the little square button on the calculator, bing, and now I've crunched out a new number. Then I'm going to multiply by each of those corresponding decimal values that I have sitting up there. So I'm going to multiply by 5010. Oops. And then I'm going to multiply in parentheses by 1 minus 5010. Here's the value that I end up with. This is 169.9579. Now notice this is a value of n, so this should be a number of people, right? These are voters I have to survey. So can I actually go survey 1,690.9579 people? Well, of course not. And if this is the minimum amount I can use, then I will automatically every time have to round up. The minimum sample size that I need should be this many people. And I'm good. When I do that, what this is telling me is I can build a confidence interval now so that, again, p hat, whatever that will be, is in the middle, but we're guaranteeing that when I build the interval, that margin of error is only going to be 2% up and down, and the confidence level is going to be 90%. So we're controlling how big the interval is going to be. Okay, I want you to try to take a look here at example number 4 and see if you can try to repeat the same process. I have 2 different parts. Okay. Again, I would encourage you to try to pause the video at this point, see how far you can get, and then maybe watch my solution for part A. If you feel like you were able to tackle that one, watch part B. But if you get stuck in part A, watch that solution, and then maybe see if you can try part B again on your own. I'll give you a moment to pause. Okay, so let's see what example 4 says. A television station wants to estimate the proportion of the viewing audience in the area that watches its evening news. So again, I'm looking for a mystery P. I want to find the minimum sample size. So it's not a hypothesis test, it's not a confidence interval, it's find a minimum sample size. And I want to estimate that proportion to within 3%, there's my E, with a 95% confidence level. Now in part A, we're going to pretend that there's no guess as to what the available proportion is. Okay, so what we know then right from the start is that P is somewhere between 0% to 100%, right? Because like we have no idea what it is. It could be anything. So it kind of exists in this interval. All right, let me go ahead then and start to write down, just like we did before, all the different values that I have. I have my E. I have my confidence level. My ZC is pretty easy to determine. Again, that's going to be inverse norm. I'm going to do 1 minus the 0.95, which would be, what, 5%? And when I chop 5% in half, I think what I end up with is 2.5%, which would look like this. My last value is my P star. And I always pick P star by saying, think of all the possible values of P, and then say, out of all the numbers in here, all of them, not just 0 and 100, but all the numbers in between as well, which of those numbers is as close to 0.5 as possible? Well, the answer there would be 0.50 is already an option in there. So that's as close to 0.5 as I can get. I can get it directly. So once I have that, I can set up my N. I'm going to do an inverse norm, 0.025, 0, 1. Divide that by my value of E, square the result, multiply by my P star, and here 1 minus P star is, well, the same value. Again, I'm going to go to the calculator to crunch out what this is. I'll show you one more time how I like to do that. I'll start with my inverse norm. So 0.025, everything else stays the same. I divide that by my 0.03. I square that. I multiply by 0.5. And I multiply by 0.5 again. So the value I ended up with was 1067.0719. And again, this would be the number of people that I need to survey. So of course, I have to go ahead and round that value up. So my final answer is 1068 people need to be surveyed. This will allow me to create the type of interval that I wish to create. Okay, again, if you didn't quite get that question, maybe pause again and try to see if you can do part B on your own. In a moment, I'll go through the solution. Okay, so for part B, here's what I ended up with. I would say that if it is known that a station's evening news reaches at most 30% of the viewing audience, I know that P is somewhere between 0% and 30%, right? It's got to be in there because 30 is the most it can get up to. Okay, so no big deal. I have the same value for E. I have the same value for C. I have the same setup for ZC. And my P star now has to be picked from what number in this range of values is as close to 0.5 as possible. Oh, well, seems like 0.30 is as close as I can get. So this time, if I set everything up and I rounded all the way up, I would end up with, let's see here. So I have inverse norm, 0.025, comma 0, 1, 0.03, square that result, multiply by 0.30 and by 0.70. I ended up with the following when I actually crunched this out, 896.3404. So I need to make sure that I round up. And so my actual value of N should be 897 people. This is how many people I would need to ask in order to be able to guarantee the kind of interval that I wish to create. Now, there are lots of problems in the worksheets that you can use to practice all the concepts that we've talked about in this video and the previous videos. I would highly encourage you to do that before you even take a look at the next video. The next video, we're going to try to see how we can start to use hypothesis tests and confidence intervals at the same time. It's not too terribly difficult, but it would be easier if you had already practiced some of the previous ideas. So I'll encourage you to go do that, and I'll see you in the next video.